On this page, this is going to be page 38 in your notes. This is going to be a few algebraic examples of isosceles triangles. So when we're finished, make sure that you glue this onto page 38 in your notes. So let's go ahead and get started. This first question wants us to solve for the variable. The first thing you have to do is look at the picture. So looking at our picture, we should notice that we have two congruent angles. And angle S and angle T would be considered base angles because they are congruent, which means that ST is the base. One thing that I really want to make sure that you always do is highlight the base. If you highlight the base, you'll always know that the base angles are equal, and the two sides that you didn't highlight should also be equal, which means that based on the fact that angle S and angle T are congruent, if we draw those opposite lines, that should also let us know that SV is congruent to TV. So the way we're going to set this problem up is we're just going to set them equal. 2x plus 6 equals 3x minus 6. So the first thing that I'm going to do, I'm going to move the x through subtraction. I get 6 equals x minus 6. Then I'm going to go ahead and add 6 to both sides. 6 plus 6 is 12. So all you have to do, if you find the base, you should be able to easily find the legs of the triangle and just set them equal. Let's try the second one. So again, we have two segments marked congruent, which means those are going to be the legs. So that immediately lets me know, okay, side CA is my base. Well, these angles, 4x plus 5 and 5x minus 10, these are located outside of the triangle. So this lets me know that those are the base angles because they've kind of got the arrow. They just don't fit inside of this picture. So they just drew it on the outside. So over here, I'm going to actually go back and add that they're congruent because you have congruent legs. On this one, these are now base angles because we have identified the base, and these are the angles sitting on the base. So that means we set them equal. 4x plus 5 equals 5x minus 10. And over here, I'm just going to put congruent base angles, just as a little reminder of how we know that those two angles are equal. Now I'm just going to solve. Remember, you can solve it any way you want to. You can get your x's together first or your numbers. So the first thing I'm going to do, I'm going to get the x's. I'm going to move the smaller x to the other side. And I get 5 equals x minus 10. Add the 10. 5 plus 10 is 15 equals x. Now if it asks what's the measure of angle C, you would just take 15 and plug it in. Okay? So again, what you want to do every single time is identify the base. Let's try the third example. On the third example, I have angle S and T congruent to each other, which is key to let me know that those are base angles, which means this side must be the base. If ST is the base, that makes the other two sides the legs. So that means I'm going to go ahead and I'm going to set those two equal to each other. 3x minus 13 equals 2x. And over here for my reason, I'm just going to put congruent legs, just as a little reminder as to how I know that those are equal. Remember, your picture is not always going to be sitting on the base. So it's very important that you look at your picture and base your information on what is congruent to help you identify the base of the triangle. So over here, a lot of you would want to move the 2x over, but remember, if you do, you end up with 0 on the right-hand side. And this is where some of you run into the issues with your negatives, when an answer should be negative, but you got positive. It's because a lot of you do your math like this. You say, oh, okay, I'm going to move the 2x over, and then you just say x equals negative 13. Because you don't realize that that's technically 0. So what you want to make sure that you do is I would always keep something on each side of the equal sign. So if I move the 2x, I'm going to get nothing. So I'm going to move the 3x instead. So negative 13 equals negative x. Now I'm going to divide by negative 1 for an answer of just 13. So it's very important that you make sure you're doing proper properties of equality to make sure that your answer is coming out to the correct value. All right, so that one's pretty easy. This whole first top piece is just us identifying the base and setting things equal. Now the bottom section is a little bit more challenging because we're actually going to have to use the lesson we talked about on Tuesday in order to do this. So let's look at the first example. First, if we're not paying attention, what you're going to want to do is set 3x equal to 90. You're going to say, oh, well, I have two angles. They should equal each other. That's not always true. First thing you always want to do is identify the base. So I'm going to stop. I'm going to look and say, okay, these two sides are congruent, which makes this my base. If YZ is my base, that makes my base angle Y and Z. And if you think back to midpoint, remember how we had to do the midpoint twice to equal the whole thing? Same idea here. If this base angle is 3x, the other base angle has to be 3x. There's no other way around it. They're congruent. They have to be the same. So if you find your base first, you'll know where your base angles are. Now we're going to take it back to page number 34 where we did the triangle angle sum theorem. These are angles in a triangle and we're trying to solve for the variable. So I'm going to just add them all together. 3x plus 3x, and we cannot forget that that box is 90. So 3x plus 90 equals 180. I'm going to combine like terms. 3x plus 3x is 6x plus 90 equals 180. Move my 90 over through subtraction. I get 6x equals 90. Dividing both sides by 6, my x value is 15. Let's try the next one. So on the next one, it's a similar type of problem. I've got side AB and side BC congruent to each other, which is easily going to show us that AC is the base. If I have my base, I know where my base angles are, angle A and C. Now, obviously this picture is a little small, but we should easily be able to see that angle A is 6x plus 6, so that should make angle C, I'm going to draw just a little arrow out, as 6x plus 6. We're going to solve it the exact same way. Add all the angles together to equal 180. So you do have to build on previous knowledge to understand isosceles triangles. The math is no different. Now you just have to understand the vocabulary. So knowing that my base angles duplicate helps me know that I need to write the 6x plus 6 twice. Combine all those like terms. I have a 6x and a 6x for 12x, plus 2 more gives me 14x. 6 plus 6 is 12. Bring down the 180. So I'm going to subtract 12 from both sides. And I get 14x equals 168. Dividing both sides by 14, x is 12. So again, in a problem like these, or in problems like these, what you want to make sure that you do is identify the base, then find the base angles, make sure that you have both of the base angles, then add everything up to equal 180. Because remember, these are angles in a triangle. All angles in triangles add up to 180 regardless of the size or type. The very last one is using that perpendicular bisector theorem. All right, so let's go ahead and start. So this is isosceles. So we should easily be able to identify the legs of the triangle. I've got this side here marked as 30, which means this side is 30. So angle P, or segment P, is 30 meters. I'm going to add that here. Because remember, they're marked congruent. Now, if this is a perpendicular bisector problem, we should remember that this segment always makes 90 degrees with the base, making Y and Z 90 degrees. It will always be 90 because it's perpendicular. We also have a bisected vertex angle, which means if this angle over here is 40, this angle is 40. So V is 40. To help us find the measure of angle X, again, we're going to use that triangle angle sum theorem. If you're having a hard time visualizing this, I'm going to go off to the side and I'm just going to redraw that triangle. Okay. So I have my 40 up here, my X down here, and my 90 in the corner. So X plus 40 plus 90 equals 180. X plus 130 equals 180. X is 50. If X is 50, that also makes W 50. Remember, the angles are duplicates. Also, X or R and S, those are base angles. So they have to be duplicates. So whatever X is, that's what W should be. So basically, you're just duplicating the triangles, one on the left, one on the right. You always have to know that these will make 90 degrees, so that helps you find that missing angle. Please go ahead and glue this onto page 38 so you don't lose the practice. And the substitute should have handed you out Isosceles triangle practice. Please go ahead and use your notes and get started on the practice.